Hello dear children, welcome you all back to another session of Amazing World of Science. So as you all know, we started lesson chapter 3 class 10 metals and non-metals, and we had completed about the physical properties and we learnt about the properties of metals, and now we are going to start the properties of learn about non-metals. Okay, now already I have learned that there are very few non-metals when you compare with metals. So what are some examples of non-metals, can you tell me? Carbon, sulfur, iodine, oxygen, hydrogen and all that. And non-metals are mostly they are either solids or gases except bromine. Okay, bromine alone is a liquid, so they will ask for your exam. So you should remember bromine is a liquid. Okay, and now the question comes whether non-metals also has physical properties which is similar to that of metals. So we will try to find out the answers to that. You collect a few samples of carbon, sulfur, iodine and all that, and again do the same activities which we did for metals, and you can just enter them into a chart, and on the basis of the observation we will discuss the general physical properties of metals and non-metals. Okay, now we have already seen that we cannot group elements according to their physical properties alone, because there will be many exceptions. Okay, for example, all metals except mercury, they exist as solids at room temperature. Metals are all solids, whereas mercury is a liquid. Okay, and metals have got high melting point. Okay, but you can see that gallium and cesium, they have got very low melting point. So just if you keep these two metals, which two metals? Gallium and cesium, in your palm, they will melt. And the second point is iodine is a non-metal. See, we learned that only metals are lustrous, but iodine, which is a non-metal, that is also lustrous. So by just looking at their physical properties, we cannot say for sure, okay, or group them. Now whereas carbon is a non-metal, but it exists in different forms. The different forms of a same element, we call them allotrope. Like diamond, that is an allotrope of carbon, and which is the hardest known substance, natural substance, which has got high melting point, boiling point and all that. But graphite, which is another allotrope of carbon, the formula, chemical symbol for both diamond and graphite is C itself. So carbon, graphite, which is an allotrope of carbon, it conducts electricity. So see, both diamond and graphite, these are two different forms of the same metal, carbon. And alkali metals like lithium, sodium, potassium and all that, they are so soft that they can be cut with a knife. We learned that generally metals are hard, but these are exceptions, and they have got low densities and low melting points. So elements can clearly be classified as metals or non-metals only on the basis of chemical properties. So we do some activity 8 here, and I have given this activity as notes at the end of the session. You can just go through it. And most non-metals produce acidic oxides when dissolved in water, you remember that, but metals will give rise to basic oxides. So remember the difference. Now we will move on to the chemical properties of metals. We are collecting samples of few elements like aluminum, copper, iron, lead, magnesium, zinc, sodium, to learn about the chemical properties. So first of all, we will see what happens when metals are burnt in air. So you have seen that already magnesium burns in air with a dazzling white flame. So all metals, do they react in the same manner? So mostly metals will combine with oxygen to give metal oxide. For example, if you keep heat copper with air, oxygen, you get copper 3 oxide, which is a black copper 2 oxide, which is a black oxide. Aluminium, if you heat with oxygen, you get aluminium oxide. So already you have learned that how copper oxide reacts with hydrochloric acid, and you know that all metal oxides are basic in nature, but some metal oxides like aluminium oxide, zinc oxide, they show both acidic as well as basic behavior. So substances, that is metal oxides, will react with both acids as well as bases to produce salt, and what are they? Are called amphoteric oxides. Remember, these are metal oxides which reacts with both acids and bases. Aluminum oxide reacts like with both acids and bases. Acid is HCl to give aluminum chloride and water. It reacts with the base sodium hydroxide to give sodium aluminate, NaAlO2 and water. So aluminum oxide is an amphoteric oxide. Okay, remember that. And most metal oxides, they are insoluble in water, but some of them will dissolve in water to form alkalis. For example, sodium oxide and potassium oxide dissolve in water to give alkalis, Na2O plus water, NaOH, sodium hydroxide. Potassium oxide plus water will give you KOH, that is potassium hydroxide. So now we saw a few chemical properties, and we saw in the activity, like we will later have given activity 3.9 also as notes, that all metals do not react with oxygen at the same rate. Different metals will show different reactivity towards oxygen. Like for example, potassium and sodium, they will react very fiercely, very vigorously, that they will catch fire. If you just keep it in open air, they will immediately react. That is why earlier I said that when you keep sodium metal and all in your palm, you have to be really careful. So to protect accidental fires, normally metals like sodium and potassium are kept immersed in kerosene. You can't put them in water because the oxygen in water will fiercely react. And at ordinary temperature, the metal surfaces like magnesium, aluminum, zinc, etc., they are covered with thin layer of oxide. So these protective layer, oxide layer, will prevent the metal from further oxidation. So they do not burn on heating. But you see, iron filings, they will burn very fiercely when sprinkled in the flame of a burner. But copper does not burn, but hot metal coated with black colored layer of copper oxide, what happens is that the oxide is always formed, but silver and gold, they do not react with oxygen at all. Even at high temperature, they won't react. And so now you understand that sodium is the most reactive of all the metals, and the magnesium reaction is less than sodium, and it comes down like that. And burning in oxygen does not help us to decide about the reactivity, and zinc, iron, copper, lead and all that. And we have to do some more experiments to find what happens when metals react with water. So the activity is given here. See, you take a test tube, and with a burner, it is fixed in a stand and closed with one hole cork, and take a metal sample. Here some glass or wool soaked in water is kept. I will give this as notes, and this is a delivery tube and a beaker, inverted test tube, and reaction takes place here. When metals react with water, they produce a metal oxide and hydrogen gas. So metal plus water, metal oxide and hydrogen. All metals do not react with water, and metal oxide plus water sometimes give metal hydroxide as well. Metals like potassium and sodium will react vigorously with cold water. In case of sodium and potassium, reaction is very violent. It is an exothermic because so much of heat energy is released, and these metals will immediately catch fire in air. Potassium plus water will give you potassium hydroxide and hydrogen gas plus heat energy. Sodium also, sodium hydroxide plus hydrogen and heat energy. Reaction of calcium with water is less violent. The heat involved is not sufficient for hydrogen to catch fire. So calcium plus water will give calcium hydroxide and hydrogen. And calcium will start floating because bubbles of hydrogen gas formed will stick to the surface of calcium. And magnesium does not react with cold water, it reacts with hot water only to form magnesium oxide and hydroxide and hydrogen. And also similar to calcium, magnesium also starts flowing due to the bubble formation of hydrogen gas. Metals like aluminum, iron, zinc, they do not react either with hot or cold water, but only with steam, forming aluminum hydroxide and hydrogen. Here iron oxide and hydrogen, and like lead, copper, silver, gold, these metals do not react with water at all. So what happens when metals react with acids? They give salt and hydrogen gas. So already we have learned that before. And metal plus dilute acid will give salt and hydrogen. But whether all metals react in the same manner, like you can write the equations for magnesium, aluminum and iron with dilute hydrochloric acid. Hydrogen gas is not involved when metal reacts with nitric acid. So, most of the cases where we look now, hydrogen gas is formed, but here hydrogen gas is not evolved when a metal reacts with nitric acid. Because why this is so? Nitric acid is a strong oxidizing agent, so it will immediately oxidize the hydrogen produced into water, and it itself gets reduced to any of the nitrogen oxide like N2O, NO2 and all that. But magnesium and manganese react with very dilute HNO3 and it gives hydrogen gas. So, you can see that the rate of formation in the case of bubbles was fastest with magnesium. Then exothermic also, reactivity decreases in the order magnesium, aluminum, zinc and iron. So, in the case of copper, no bubbles were seen and temperature also was same, and which say that copper does not react with dilute HCl. And next, how metals, reactive metals can displace less reactive metals from their compounds in solution or molten form. It is nothing, we will do one activity here that also I have shown already. Here 2 test tubes are there, we are tying a thread and see here iron nail immersed in copper sulphate solution, iron sulphate solution and copper wire. Okay, you can take out the iron nail, and what happens is that the reactivity of various metals with oxygen, water and acids already learned, but all metals do not react with the reagents. So, we cannot put all the metal samples from this in decreasing order of reactivity. So, metal A plus salt solution of B will give salt solution of A plus metal B. See, it is going cross. So, that is the displacement happening here, and from that we can make a chart which is known as reactivity series. So, what is the reactivity series? It is a list of metals arranged in the order of their decreasing activity from top to bottom, it goes on decreasing. So, after performing displacement experiment, we get the following series. It has been developed. See, potassium is the most reactive, coming like this. See, reactivity goes on decreasing, whereas gold is the least reactive. You must memorize this: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, and these 4: copper, mercury, silver, gold. These are the least reactive. We will explain in detail about the reactivity series in our next session. So, children, you do kindly share the session video with your friends and ask them to subscribe to our channel, and we will be uploading more such useful and informative sessions to you one by one. And thanks for watching, and I will be uploading the next session soon, and do put any suggestions as comments in the comment box. And that is all for today. Bye bye.